We will begin today's class with business analytics, uh, methods, models, and decision. Chapter 4, which is descriptive statistics. Okay, if you have any question, just inform me. Okay, if there's no voice or there's no anything coming out, you just inform me. Yeah. Okay. Right. So we shall begin with today's session. Okay, I just finished class just now, Fin 435, which is your junior. So now 8 to 10 class, and now we move on to 10 to 12 class, online session. Today will be regarding chapter 4. We already went to chapter 1, chapter 2, and chapter 3. So chapter 4 is regarding descriptive statistic. The descriptive statistic is already, you will see in this keyword, descriptive, derived from the word describe. Okay, you try to describe what have you actually, the information that you actually have gathered. Okay, you gather, how that you gathered, how that you collect this information is through survey, for example, or you try to get it through secondary data, which is you go to a system, or you take a panel data or time series data, and then when you try to make it easily visible, you try to convert it into a data that will be available in the form of percentages, or you want to it to be in the form of average, and or you want the data to be easily identifiable, meaning that each of these data you can pinpoint what is the minimum value, what are the maximum value, what is the average, how many, what are the total number of, for example, in terms of gender, what is the total number of male, what are the total number of female. So from there, you will know um, the actual value of the data that you actually collected, and the readers who are the viewers of your data that you met, that you analyze, you want them to visually remember or visually take the information into for the purpose of it is being easier to be recognizable. So describing this data in the form of statistics. So statistics, uh, when I mentioned just now, was in the form of minimum value, maximum value. Is it in a, dollar form, which is a currency value, or percentage value, or is it in a decimal point? So descriptive statistics not only emphasize on numerical values, but it also can be in the form of charts, in the form of trend lines, and so forth. So what we intend to learn here is one of the things is, of course, using Excel later on. So from the Excel, from the data, which I'm going to share with you, and this data is actually already inside the UFuture folders. But never mind, I'll share it with you in the WhatsApp group later on. So from those data sets later on, we can actually create, okay, descriptive statistics. Okay, so there's a few data sets that we can practice later on. So we'll be using those data sets later on in order for us to uh, know what is chapter 4 is all about. Right? So now we move on to the next slide. So we look at the definition that has been made by one of these individual called David Henn. So according to him, statistics involve collecting, organizing, analyzing, interpreting, and presenting the data. So it is a statistic of a summary of measured data. And descriptive statistic refers to a method of describing and summarizing data using tabular, visual, and quantitative techniques. Okay, so this is a very good summary that summarizes the purpose, the role, and how you use statistics. And in descriptive statistics, already describing the statistics, you want to describe it in a presentable manner, because not everyone have the capability of actually understanding statistics. So what we want to do is we want to simplify it. We want to make it visually friendly to everyone. Generally, we want to make it generally attractive as well, easily recognizable, and is presentable for everyone. So our job here later on will be to describe the statistic using Excel. Okay, so Excel is one of the we would say software, okay, that is used to help you, okay, to assist you to simplify all of this data, because we know that data set is just a data, a mass data. It's too much information there, but sometimes we just want one or three particular data, and from there you summarize the data using this technique, which is called descriptive statistics. So to classify this data, we have metrics. Okay, metrics, which is a unit of measurement that provides a way to objectively quantify performance. And then we have measurement, the act of obtaining data associated with metrics and also measures. It could be in numerical values associated with a metric. So metric can be centimeter, for example, kilogram, and so forth, right? For discrete metrics, for example, a delivery is either on time or not. An order is complete or incomplete, or an invoice can have one, two, three, or any numbers of errors. So some discrete metrics would be the proportion on on-time deliveries, the numbers of incomplete orders each day, and the numbers of errors per invoice. So some discrete metrics would be in the form of proportion. Proportion meaning percentages lah, percentage. Okay, how many percent? Okay, 30%, 20%. Okay, number of incomplete orders each day. So I can categorize it from Monday until Sunday. Okay, and the numbers of error per invoice. So we will understand this by actually knowing the type of metric that is being used for the descriptive statistics. So we also have continuous metrics. So continuous metrics are based on continuous scales of measurements. For example, any metrics involving dollars, length, time, volume, or weight, for example, are continuous. Okay, you do not have like hours, right? Hours is not continuous because hours will normally stop at a certain particular time, right? We do not have uh, time more than 12 a.m. We don't have 13 a.m., 14 a.m., although you can change it to that. But what I want to say is continuous are something like dollar. Okay, we have infinite amount, maybe infinite amount of length, okay, volume, and so forth, right? So the next one is scales, okay, categorical, okay, nominal, data. Okay, so categorical can be in the form of categories such as female, male, and we have ordinal data, can be ordered or ranked. For example, strongly disagree until strongly agree. That means if you're using a Likert scale, from a scale to 1 to 7, so 1, 2, 3, 4, 5, 6, 7. So ordinal data will be measured in that particular way. So you have strongly agree, um, which will be indicated or labeled as 7, and strongly disagree will be 1, and neutral will be around 5 or 4. Okay, so that is what it means by ordinal data. And we have interval data. So interval data have constant difference between observation and have arbitrary 0 point. Okay, ratio data continuous and have a natural zero. Okay, so interval data, what are the examples of interval data? Okay, you have to find out. For example, is it degree Celsius? Okay, temperature, ordinal interval data, or ratio data, continuous and have a natural zero. Okay, for example, what we say as time. Okay, so how to classify data? So here is an example for you to see what are the types of data in a data set. Okay, we have categorical, category hulky fasteners, okay, alum shedding, fast type aerospace. So all of these are categories. Then we have ordinal, meaning that it is being uh, labeled accordingly, okay, according to maybe the time that it was registered into the system. So you need to have a coding. So this coding follows a certain uh, uh, or order lah, certain order. So the first order, the second order, the third order, and so forth. So that is will be labeled as ordinal, and we also have categorical. We have ratios. Here ratios, we can see that is in decimal points, and then we also have interval. Okay, for dates lah. Okay, so far so good. Okay,
Okay, okay, sir.
all right. So moving on, our slide number 7. So we have population and also sample. Okay, we must know the differentiation between population and also sample. So what does population means? Population is all the items of interest for a particular decision or investigation. Meanwhile, sample is a subset of the population. So sample is the larger aspect and population is one of the aspect in the sample itself. So for example, we look at the example of population. So all married drivers over 25 years old and all subscribers to Netflix. Meanwhile, for sample are a list of individuals who rented a comedy from Netflix in the past year. So it's quite broad when you look at samples, but population will simplify it, will directly emphasize or highlight a certain metrics. Okay, so the purpose of sampling is to obtain sufficient information to draw a valid inference about a population. And we also need to understand the statistical notation. So this is what we mean by uh, estimation. To estimate, we have to have an equation. So in an equation, it will help us to understand the relationships. Okay, maybe we want to know the relationships between the independent and the dependent variable, or we want to know the summation, okay, the weightage, or the overall average. So what we do is we have to understand the representation of this from the equation. So equation will tells you what does each of the variables represent. Okay, for example, we have here, it is common practice in statistics to use Greek letters such as this one look like a U, right? Called mu, or this O, sigma, and pi, which represents population measures, and italic letters such as by this one, mean, okay? S and P. So these are all representative of a particular variables. So for instance, to have an equation that represents the mean for the population, we use the first one. And then sample mean, then we also have average, property of mean, and so forth. So these are some of the examples of equation. Right? So again, here we have the example whereby they use the purchase order database. Okay, for you to have a clear picture of how mean is calculated. So mean is, what does mean means? What does mean means? Okay, mean is average. Okay, meaning that the total number of order, if you can see in this example here, the slide, the total number of order is being totaled up and then divided by the numbers of order, which is 94. So 2,471,760,000 million divided by 94, then you get the average, which is the mean. Okay. Meanwhile, the median. Okay, the median specifies the middle value. Okay, if you have a data set of 100, data set, that means the median should be around 50. What if you have 101? So 101, then the median value would be labeled as 50 plus 51 divided by 2. Okay? So that is how do we try to identify what is the midpoint of a data set. Okay, here we have an example. Okay, if the number is what do you call this? You because we need to find the midpoint, right? The middle number for a data set. That means you have to divide it by 2. Okay, then you find the median. So mean is the average, median is the midpoint of the data set, the middle value. Okay, and of course, mean, after mean, we have median and mode. Okay, mode is the observation that occurs most frequently. For example, if you have a data set that have a lot of 5, so you have 1, 2, 5, 4, 5, 3, 5, 6, 7, 5. So you notice that 5 has been mentioned multiple times, right? So that will um, signify or represent as mode. So mode is the observation that occurs most frequently. So it can not only represent numerical values. Okay, what if you want to observe a certain occurrence, right? For example, sound, okay, a different kind of sound, and then suddenly there's a lot of high pitched sound compared to monotonous, low, and slightly loud. But there's a lot of high pitched sound being recorded. So that is the mode. Okay, that is the mode because from the observation, it occurs most frequently. So now you can see that how what is the purpose of descriptive statistics. Okay, descriptive statistics will help to identify or to help to tell the viewers what is going on within the data set itself. Okay, based on what do the viewers or the people who actually read your analysis would want to know. Okay, so here we have a purchase order database. Okay, mode is the 30 months, and then cost per order, mode in the group between 0 to 13,000. Okay, mid-range meanwhile is the average of the greatest and least value in the data set. Okay, so use the Excel min and max function or sort the data and find them easily. Let's purchase order data. Okay. Are we going to the data now? Let's see. These are all very easy to use. Okay. So all of these are still within the min, max. Okay. I think we've done this in chapter 1 or 2 using the Excel and identifying where and how to use the Excel function tab, which is the min and max. Okay, now this is just repetitive. What we want to see is this one. Okay, we move on to this slide number 19. Okay, so far, okay, so good, right or not?
Yes, sir.
Okay, I try to see if they need you to use the purchase order cost. This is okay, never mind. I think there's an exercise, right? At the end of the slide. No? No. Never mind. Hmm. I'll try to share with you this first. I'm no longer sharing, right? Okay, I'm no longer sharing. So let's go to the slide, purchase order. Okay. Oh, there's a lot of data set here to be shared with you. So I think this one is order. Eh, no, not this one. Oh my gosh. Wrong. Wrong. Okay. 534. Okay, this one. Okay, so everyone, I've shared with you the Excel data set. Okay, and all of this you can actually practice. Okay, using this data set, practice it, and then determine how to use the min, max, variance, and so forth. But before that, of course, I will share with you how to actually use it. No worries. Let me share. Where is the slide? Here is the slide. Share window. Oh, no, not yet. Okay, now, let me drink first. So, this question, so this question, So dispersion refers to the degree of variation in the data, that is the numerical spread of compactness of the data. So imagine if you were looking at what you call this, have if you ever play archery or archery lah. So there is a target that you need to shoot at, right? So when you shoot the arrow from your bow, it needs to hit the bull's eye, right? So from the center point of that target until the outer point, there's a few marks there, right? So meaning that if you are a good shooter, so when you shoot at the board, the the place where you shoot your arrow, so if you shoot the bull's eye, right? So normally you get a higher mark. And if your arrow would to hit outside of the bull eye or beyond the mark, the target board, so the mark will be lesser outwards, right? So essentially here dispersion. So when we do observation, for example, we want to observe some natural occurrence or the sales of a particular products or services or the production of a particular uh, food F&B. So for example, a company, Coca-Cola, for example. Anyone drink Coca-Cola here? When you drink Coca-Cola, right, you want to have the exact amount of volume. For example, one can, for example, is 50 milliliter lah. Is it a lot? 50 milliliter. So in order, because Coca-Cola produces tons and tons, millions of cans every day, right? So they have to have a standard because they are a well-known brand. So when they are a well-known brand, they have to have a standard quality assurance that each can have at least 50 milliliter, and how to actually have a good quality so that all the cans around the world Coca-Cola have 50 milliliter is by assuring that they have data of this production. So when each can is produced, the data is being collected. So it will pass through a machine or some kind of machine lah, which actually make sure that it will produce 50 milliliter, 50 milliliter, 50 milliliter for all the millions of cans produced around the world. So this data will be stored and will be described, okay, in descriptive statistics. Of course, there is sometimes slight difference, okay, 49.999, 50.1, something like that lah. So if you have 4.9 and 5.1, so as a quality assurance, there is a guideline lah. So that the threshold you could not exceed 4.8 and 5.2 because you know the machine sometimes could not actually have, because there's a lot of factors. So when you have dispersion, so that means that sometimes there's an outlier. Some of the can produce become 5.3, some become 4.5. So from there, from the data, then you would discover, oh, actually there is a dispersion, a variation of data. So from this data that is being collected and then being described in statistics, because it's visually easily recognized. So that's how big multinational company make use of descriptive data to actually making sure that the quality is being preserved. Okay, so that is part of how this is being applied in the real world. Okay, so one of the few key measures that is being used, one of it is range, second is variance, and the third one is standard deviation. What is range? Okay, range is the simplest and is the difference between the maximum value and the minimum value in the data set. So once, because we went through this, right? We went to calculate with each other. I've shown you how to actually use maximum value, how to find from the data, and minimum. So when you minus these two, you will find the range, which is affected by the outlier. And it is often used only for very small data sets. Okay. Next. So from the purchase order data, for the cost per order data, the maximum is 1 to 7 and the minimum is 68. Okay. So we go to the slide. Okay. Let's go to the Excel sheet of purchase order. Save to download. Go to download. Okay. Let's go. Save. Right. Yes. Share screen. Share entire screen. Okay. Hopefully you can see this. I know it's quite small, but we try. We try. So this is the purchase order database, data set. Okay, if you notice that I've already given to you, shared to you through the WhatsApp group. So I think the first Excel sheet is the data set. Okay, I've already downloaded this and open it now, and we will see a lot of data set here. So we want to know the maximum value of cost per order. So we have cost per order in column G, right? Here. So we want to find the maximum value. What we do is we just equal sign max. Okay. Click on max and we highlight all of this. And once we're done with that, we close the bracket and we press enter. So we can see the value, the most highest value that is in this column for cost per order is 127,500. Okay, and then next we want to find the minimum value. So we'll press equal sign, which is on your keyboard. You just find equal sign, which is on your right hand side of your keypad, and you go ahead and click minimum, okay, MIN. So click on minimum using your mouse or your pad, and then you also go ahead and select all of this, which is in column G, and now you close the bracket. Okay, remember always to close the bracket and go ahead and press enter, and there you have it. You have the smallest number within this column. Now we want to find the range. What do we do? So you can equal sign as well. Press click on this digit number 1 to 7 and minus on your keypad. There's a minus sign. Press the second value 68.78. Okay, and then press enter. I hope it works. Okay, yes, it works. So it is 127,431.22. Okay, I hope you're following me. Can you follow?
Yes, sir.
Alright, good. So next one. Oh no. Okay, next one from the slide. Next is about variance. Just now was about range. Now is variance. So variance is the average of the squared deviation from the mean. So for a population, okay, for example, var dot p, this is the what we call as the equation, the equation here, and then we have, if you were to use the Excel, you would type var, equal sign var dot p. Okay, see, purchase cost per order. Okay, okay, what they want you to do here is sum of cost per order. Okay, we can do this. So we try to do variance together. Okay, try to do variance together. Now we have the observation. Okay, we have 94 observation, is it? Let's see. Yeah, around 94 lah. Okay. Right. So cost per order. So we want to find this value, 2,471,760,000. Okay, so now what we do is, to find the sum of cost per order, we just equal sign, okay, sum, and total up all of this. Right, then we close the bracket. Oh, tidak mau. Kenapa? Sangat kecil. Okay. So now we have the same value, right? 2,471,2,780. Here we also can see the same amount here. Next is the number of observation. Of course, you can you can see from here lah. What you do, what do I normally do? I select this, and I'll see how many. Okay, 94. 94R times 1C. So that means there's 94 observation. Alright, 94. So you can go here and put 94. Okay. Now this is the tricky part. Sum of squared deviation. What do you need to do? Squared. So mean, right? Mean, let's see, mean is average, right? So what we do is equal sign, this one divided by the total number of observation, we will get the mean. Okay, so this is the mean. Right, so that is the mean. This is n, number of observation. This is the sum. Now we want to achieve this column C here, meaning that this 82,875 minus the mean. So all of this will minus the mean. What do we do? Normally, what I do is, I'll copy this, put it here. Oh, tidak mau. Z. Okay. Copy, which is Control C lah. Okay. And then paste special, put values. Okay, now you have this value. Okay. Now drag this until down. Alright, so this is the mean. And then we want the xi, right? Xi. So these are the xi. Where are you? This one. Okay. These are all the xi. Copy. Also paste special values. Now, what we do is this xi minus mean, right? Xi minus mean will give you the required number. So xi equal sign first, xi minus mean. Oh, sorry, mean. Enter. Okay, so now drag everything. So there you have it. Let's see, is it the same with this? Yeah, it's the same, huh? 56, 16, 21, okay, the same. Then we want to find this part here. So all of this will be square root. Square. How to do square? Where can you do it? Okay, then square the I don't know if this is possible. Oh, it is possible. It is right. Okay. So how did I do this? I use this thing, square to then drag. Okay. So now we have the same amount. So they need you to find the sum of squared deviation. Okay. Which is this one, So sum of square deviation, sum of square deviation, okay, which is equal sum this one, right? Plus the so you can see that it is same, 82, okay, Now we want to find what we want to find. What else? The variance. 96. Okay, D96. Where is D96? D96, which is this one, divided by 97. B97. Okay, B97. Okay, then you find the variance. So then now only you can actually find the variance. So you can see that the road to variance is very long compared to range, right? So variance, in order for you to do variance, you have to find this, you have to find this, find this, do this, and then only you can reach the variance. Huh? So you have to uh, keep practice, a lot of practice lah actually. So D96, which is this one, okay, will, what happen? Will divide by the number minus 1. Ta-da! Okay. And then the last part is the standard deviation. So we can go ahead using Excel, var var.s, right? Function. Why is it? Okay, var.s function. Okay. Now, oh, okay, it's the same thing. So this is finding the variance. Let's try, let's try var.s. Okay, now I know. Okay, so we got here. We try to find var.s. Okay, we found it. Insert function. What do they need here? Estimates variance based on sample. Ignores the logical value. So they have an explanation here. Numeric point. Let's see. This one. Find this one. Ha, easy kan? Can you see this? Okay. So they already tell you the number here. Done. Kan? It's much more easier. So just now I was showing you the manual way, right? We did the manual way, but the easy way is just to use this, okay? Right? We just go ahead and put all of this in column G inside this function, and it will immediately give you this result, okay? But in order for you to understand what this variance is all about, is basically we were doing the manual part, and we were actually achieving, right, the same result here, okay? So I hope it is clear regarding variance. Any question?
So far, not yet, sir.
Okay, stop presenting. Okay, let's go to the slide. Share window. it's not enlarged? So just now was the examples of actually using the function tab and also manually doing it in Excel in order to find the variance. And now we have standard deviation. So it's basically almost the same thing, right? Whereby you just the value was 890, so you just square root it and then you can find the standard deviation. Or you have an alternative way, which is just directly using the function tab and using the function of stdev.s, and you highlight all the columns in column B from row number 2 to until row number 95. So this will get you the same exact number rather than using the manual way. Okay. So this is how you measure standard deviation lah. You can even try it by yourself. Okay, to identify what is the standard deviation for Intel, General Electrics, and so forth. So standard deviation tells you what is the, for example, the one that I mentioned regarding the Coca-Cola. Remember that each can have to have at least around 50, right? 50 ml. So that will is part of identifying the standard, okay, the standard deviation. You want it to hover around that area. Okay, so that will, from a lot of data that is being given, the data has been collected, so it's being transcribed and being described and analyzed, and so that you will know what is the standard that should be achieved for each of the unit of production. Okay, right. Let's go. Skewness. Okay, skewness describes the lack of symmetry of data. This distribution that the tail of the right tail are called positively skewed. Thus, the tail of to the left are said to be negatively skewed. So we have negatively skewed and positively skewed. Okay, so we can see from this um, the line, right? The line, the trend line here, or the data line here, we can see that if you were to, because we will see from 0 to 10 or 50, right? Which is, you can see the tail here. So if the tail is skewed to the other side, that means there are less points that is being recorded on the tail, okay, rather than if you see there's the peak there, that means a lot of information is actually recorded there compared to the end of the tail. So this is what normally charts represent. Okay, we want to know where do most of the recorded values observation is being shown or being recorded. So we want to see, is it within the median or within the mode or within the mean. Okay. So although when you do the calculation, when you do the descriptive statistic, you will notice that even the mean is away from the recorded numbers of observation. Okay, because we have a lot of outliers which is will be sitting on the tail itself. So it's either positively skewed or negatively skewed, meaning that there is it more recorded values that are outliers within the positive side or on the negative side. Okay, this is how to manually calculate the skewness. Okay. So if you can see from the cost per order, it is recording a very high positive skewness, and for AP term, it is more symmetric. Okay. Kurtosis refers to the thickness, high, narrow, or flatness of the histogram. Okay, so less than 3 of kurtosis indicates the data is somewhat flat with wide degree of dispersion, and more than 3 will indicate the data is somewhat thick with less dispersion. So that means that if you were to shoot an arrow and is a very sharp histogram, right? That means the peak is very high, and there's no tail. That means you are very accurate, okay, accurate, because you shoot at one point. You always end up shooting at the same point, and based on the observation, the histogram, the thickness is very high. If you have a very flat histogram, a very flat line, that means when you are shooting the arrow, right? Um, your mark, your observation might be here and there lah. It's not you're not aiming at one point, but your arrow end up in multiple areas of that target. So that's why your histogram, when you try to chart, mark the line chart, your points are here and there. So that is how the chart end up to be flat. Okay, it's not peak. So it's just a way to address what is going on in the observation. Same thing like the Coca-Cola just now, right? If a lot of the Coca-Cola volume within the can is uh, producing a lot of observation which is not within the threshold of 4.9 to 5.1. That means some even go for 3, some go for 6, 7. That means the histogram chart will be kind of flat compared to it is showing a very sharp peak histogram. Okay. This one, right, measure of association. So how many more slides we have? Okay, so next one is measure of association. I think you cannot view it, right? Okay, let's see how many. Association. Okay, let me drink first. Huh? Wait, I'm not sharing it with you. Share, share window. Okay, continue to share. Okay, measure of association. So in statistical um, relationship, we try to connect. Okay, for example, we want to know why did there's a outlier from shooting the arrow. Okay, so is it because you didn't train enough? Okay, the training hours was not sufficient. Maybe should we increase the training hours of shooting the arrow so that you can get a more accurate mark from shooting the arrow? Or how about for the Coca-Cola just now? Why is there a major dispersion of quality wise? That means it doesn't have a constant 50 ml throughout the production line. So what could be improved here? So there are many variables, many factors. So these factors are uh, external, internal variables that could influence the relationship in actually making sure the quality of the Coca-Cola achieve 50 ml throughout the production line, or you also want for instance the example of shooting the arrow just now, making sure that throughout the shooting of the arrow you will always have a bull's eye. So what are the factors? So we want to quantify it and to describe it in a numerical way. So there is a way to find out what is the association. Is it a positive relationship? Is it a negative relationship? Or is it significant? Let's say if you were to add in more training hours so that the shooting of the arrow would be accurate, so is it significant? Should it be applied, or should you instead um, address the wind factor? Maybe the wind is too strong that time. Should you uh, shoot at another time, maybe in the evening or morning or at night? So there's a lot of variables that you can actually associate with the result. Okay, so that is what it means by using statistical relationship to change the variable. Okay, the result, the end result. So what is covariance? A covariance is a measure of linear association between two variables, which is x and y. So normally we have the independent variables and the dependent variables. So dependent variables will depend on the independent variables. For example, like the shooting of the arrow. So in order for you to have a bullseye, what will be the independent variables? So the shooting of the arrow, the result will be the dependent. So the bullseye will depend on the training hours. That is one independent variable. What are the second independent variable that you can think of? Secondly will be maybe the sleeping hours of that person. Has he slept enough? Have he rest enough? Is 6 hours enough for him to actually achieve the target of bullseye? Or 8 hours? Is it too long? Another one, maybe the food. Okay, maybe you can test food, but how do you quantify food? That's another thing. Okay, maybe in the form of kilogram. Okay, the calorie intake, right? Calorie intake. So calorie intake, how much starch, how much protein, and so forth. So these are variables. So this is how that you can use statistical so, so so hard, statistical, mathematical formula and everything to do analysis. Okay, you see this in for football players even. Football players, they use this kind of, you don't say that, oh, this kind of level of mathematical would not be applied in real world next time. Yes, it would not, but if you are suddenly asked or tasked to do this thing, then you would know, oh, okay, this is actually something important. Okay, so this is applied actually in various many kinds of um, real world cases. So part of it is trying to identify the association through covariance. Okay, so what are the sample covariance? We can see that it's being used um, manually here, and also if you want to quickly apply, identify what is the covariance, you can head on to use the function tab. Okay, which is you just press equal sign in the Excel, you type covariance, and you select, highlight the column or the row that you wish to know what would be the covariance. Okay, normally covariance will be having two ranges. Okay, you need to highlight two range because you want to know the association. What is the covariance? Okay. So this is what I meant by the histogram. If you were to observe uh, on your screen right now, in slide 39, there is a chart, okay, a chart which is not being charted yet, only observation. And you can see that most of the observation are within the range of, let's see, 1 to 1200 till 1360, something like that, and 1400 is the outlier, or the 1150. So you can see that it will represent some kind of a negatively skewed chart, right? If you were to draw a line there. So the covariance is 263.37. Okay. So they want to know the college and the graduation percentage versus the median of the SATs. Okay. That let me see, 95% of graduate and 70 around 75 to 95% graduates will achieve a median SAT between 1200 to 1350. Okay, so this is just a mental picture. Correlation. If you want to know the relationship, just now was covariance, now is correlation. You want to find the linear relationship between two variables. Okay, here it is. Okay, we need to see, is it a positive correlation? Is it a negative correlation? So what is a positive correlation? For example, if you were to water a plant, okay, the more water you give to the plant, the taller the plant grows, right? For example, okay. But if you water the plant too much, the growth of the plant will be stunted or reduced. Okay, so you will have a mental picture lah of a graph. That means the graph will grow and reduce. Same thing like, for example, handphones, right? If you have too much handphones, if you were to sell a handphone, a new handphone, then you will see the graph will rise, right? So this dotted will represent maybe the buyer, the number of purchase. Okay, so after that it will reduce at the end of the time, because the demand reduces because there is a new phone or there's too much phone in the market. So the price to number of phones purchased. Okay, something like that. Okay, we also have no correlation. That means the um, for example, if you were to shoot the arrow to the marks to the board and then there's too much dispersion, that means there's no correlation. Or there's no non-linear relationship with no linear correlation. It will look like that, like this one, like graph D, chart D. Okay. We also have correlation coefficient. Right. So this one, let me see. Excel computes the correlation coefficient between all pairs of variables in the input range data, and must be contiguous columns. Okay, investigating outliers using the Z score. If it's exceeding 3, then You can see that here is the last observation has a high market value but relatively small house size. So this may be an outlier. Okay, finish. So maybe we will try to do some exercise. I will try to post it in new future later on, and you'll try to do it. Okay. So I think that's all for today. Don't forget your attendance. All the data is being given to you in the WhatsApp group. Okay. And you try to do the exercise. I'll try to post it in the WhatsApp on for you to try to do it. Let me end the recording session. Finish recording. Stop recording.